Okay, so last lesson, okay, we were learning about how to use the CAS to make your histograms and to put your numbers in a Excel sheet like this. Okay, and then it turns it into that. Okay, today our focus, okay, is going to be on just describing your graphs, okay, your histograms, describing the shapes of it. Okay, so there's mainly in year 11, there's only really three shapes that we get you to use for your graphs. Okay, there's your positively skewed, negatively skewed, and your symmetric. Thanks, Ben. Or approximately symmetric. So when you're looking at the shape, all you're really thinking about is if you imagine like a mountain on that, you describe the shape of that mountain. That's all it is. Okay, that's how I explain it. You're just describing the shape of that mountain. Where is it? Okay, and that where it is will determine the shape of it. Okay, so if you look at something like this, data that looks like this, where it starts low but it starts high like this, and then it goes down for the rest of the way, it's positively skewed. So think of positively skewed. You start high and then you go down. Okay, negatively skewed. Think of it as you start low and then you go up. Okay, so that's negatively skewed. Another way you can think of it is have a look at where the modal interval is. Where's this modal interval? This guy. If your modal interval is more on the left, positively skewed. If it's on the right, like this, then it's negatively skewed. Okay? So basically, describing the shapes of your graphs, you've only got those two options for now. But the third option, okay, I should put that in. The third option is symmetrical. Okay, you've got two options for symmetrical. Normally, what you'll hear or use most of the time is approximately symmetric. Data isn't always going to be symmetric. Normally, approximate is what you'll use. So you only have three options. Okay, you've got approximately symmetric, positively skewed, or negatively skewed. Those are your three options when you're describing data. Okay, just keep that in mind. Sometimes you'll be also talking about the spread of the data, of where it might be located. When it talks about spread, you're looking at data that has similar qualities, but the only difference is where on the number line they're located. Okay, so here for histogram E, similar in shape to histogram F, okay, but the location is different. Here the lowest is 3, and the highest is 11. Here the lowest is 8, and the highest is 16. Okay, so the location is just saying, for example, histogram F is located higher on the number line, okay, compared to histogram E. Let's see what else is here. So if you look about, if you're talking about spread here as well, it's a little bit different. This spread here compared to this spread here, okay, you can see that here the data is a lot more together, so it's not as spread out compared to the data here, okay, which is way more spread out. So there's a lot more data towards the middle here, whereas here there's more data being disseminated towards the rest of the graph. Okay, so you can say, for example, something is more spread out when you're comparing two histograms together. All right, pretty straightforward. And that's basically it for 2E. Okay, let's just go straight into 2F, and then we'll do that. Actually, no, let's take a break.
Yes, sir.
All right, so let's go to 2F and look at the dot plots and the stem and leaf plots. So basically, a dot plot is as it says here, probably the most easiest way to represent data. If you don't know what a dot plot is, it's basically a number line. You've got a bunch of numbers and then there's dots on top of them. Okay, and it tells you how much of that number there is. Okay, in the number line, you want to make sure in your number line that you don't skip any numbers. So don't do this. Don't go 1, 2, 7, 8, and then 11. Where's the rest of the numbers? Okay, don't skip them. Just put all the numbers in there if you have a number line like that. Okay, so for example here, for this dot plot, we're going to put these numbers in. You can see that there's numbers here that they've been recorded and they are referring to the hours worked by 10 students. So you've got how many 4s? You've got one 4, so you put a dot on top of the 4. You've got 2 5s. Okay, you've got 1, 2, 3, 4 6s. So 1, 2, 3, 4. You've got 1 7. Okay, you've got 1, 8, and 1, 9. Okay, and there's your basic dot plot. Nice and easy. Always make sure, again, don't skip on any numbers, because yeah, it'll be marked incorrect in your exam if you do that. Another thing as well to include is put the name of your dot plot. Similarly, when you make a graph, you always put a name on it. Make sure you put the names on it. Okay, stem and leaf plots, straightforward as well. Although I do know that in year 11, some kids do still struggle to read a stem and leaf plot. Okay, that's okay. So in a stem and leaf plot, okay, for example, here you've got numbers for a group of students in a test. Always read the context as well, so you know what you're actually looking at. So these are their marks. And I can see that the numbers range from a minimum of 2, and it looks like the maximum is about 60 something. Yeah, 60, I think it's 60. Probably 60. Okay, so 2 to 60. All right, so we're going to display this data in a stem and leaf plot. Now, really important that you know how to read a stem and leaf plot. Okay, it's split up by one line in the middle here. Okay, the numbers on the left represent the tens units. So for example, how do you read this number? That's the number 2. But I've just put a 0 there to tell you that there's 0 tens, 2 ones. How do we read this number? 10. Okay, what about this number? 93. Okay, so there's 9 tens and 3 ones. So in a stem and leaf plot like this, you always put the tens on the left hand side, and then all the ones on the right when you split them up. Sometimes you will get a double stem and leaf plot that looks like this. Okay, where you've got boys maybe, and it might be girls here, just as an example. Okay, but we'll stick to this for now. So for this stem and leaf plot, what we're going to do is put these numbers in there, but we need to put them in order from lowest to highest. Okay, really tricky there, because if you don't, then it's going to be incorrect. Okay, so what I like to do is I just like to mark them out as I go. So I can see 2 is the lowest, so that's already been done. So is 15, that's been done. We can look for the next number. I don't think there are any 16s, no 17s. I think the next is going to be 19. So you've got 1, 2, 3, 19. So here you're going to go 1, 2, 3. Okay, so there's all the 19s.
Put the comma or not?
Yeah, put the comma so you can split them between the numbers. Okay, another thing, the next one is going to be the 20s. So is there anything from 20? Well, there's a 20 there. No other 20s. So for the 20, you go 2, 0. Okay, no 21s, no 22s. I think the next would be 24. So you got 1, 2 24. So now we go 4 and 4. 2 25s. So the next would be the 2 25s. Cross them out as you go. That makes it a lot easier, so you're not having to look at everything. 3 28s. So 1, 2, 3. So cross them out. Next, I'm assuming is the 30s. Yep, so you've got 1. How many 30s? Just the 1? Okay, cool. So cross them out as you go, yeah, guys, so you don't get confused. So look, I'm only focusing on these numbers now. I can see the next is 33. So there's 1 3, 2 35s. So we go 5 5. There's 1 36. Thank you. Next, you've got a 38 and a 39. Yep, 41, 43, 42. So cross them out as you go, and then there's a 45. Yes.
Does it have to be in order?
It must be in order.
Because that's not in order.
Oh yeah, sorry. 42, 43. Thank you for catching that. And then you've got 60. So there's no 50s, but there is 160. Okay, so our stem and leaf plot should look something like this. Always make sure it's in order. Okay, you don't necessarily have to rewrite the numbers in order, but in your stem and leaf plot, they must be in order. Right? They have to be. Now, one thing that I have to mention here, okay, for a stem and leaf plot is you have to put a key in here. Okay, because we don't know if you're supposed to read these numbers as 1 5, okay, means 15. So that tells me that's how I read it, because sometimes you get a stem and leaf plot that looks like this. 2-3 equals 2.3. Okay, you have to have a key in there to tell me how to read these numbers. Okay, so this is what a key is. Okay, you have to include them to tell me how you read these numbers. So another example could be 5-3 equals 53. Or it could even be this. 23-4 equals 234. Okay, you have to include a key. Or it could also be 23-4, it could also be 23.4. That key will tell you how to read the numbers, so you have to include it. All right, let's go to the next one. So choosing between what plots you should use. If it's a small number of data, just use a dot plot. If it's less than 50, it says here, use a stem and leaf plot. But if you have a lot of numbers, use a histogram, yeah? But basically, dot plot, stem and leaf plots, you can do it by hand. But if it's a lot of numbers, use your histogram and use your calculators. Okay, sweet.